this module, we will examine a number of spatial design approaches that can be utilised for improving sound performance. In this presentation, we will cover room spatial layout considerations, the impact of windows and door locations, and the different material options for these products, and the impact of placement and location of services such as water and plumbing. We will then summarise some of the do's and don'ts for a typical apartment layout. Sound performance can be quite dramatically impacted by the form and spatial arrangement of the building design. In addition, most end users of dwellings will want higher sound performance than the minimum levels specified in the NCC. In addressing this desire, this module focuses on ways to improve and upgrade sound performance. The Australian Buildings Codes Board also provides an excellent free handbook on its website explaining some of these considerations. Firstly, ensure that the room layout is beneficial rather than detrimental to sound transmission. This illustration shows good practice where noisy areas adjoin noisy areas and quiet areas adjoin quiet areas. Avoid wherever possible this layout where noisy areas adjoin quiet areas in neighbouring SOUs. This is bad practice. It is also good design to try and ensure that service rooms in one dwelling, such as kitchens or bathrooms, back onto the same type of rooms in an adjoining dwelling, rather than backing onto habitable rooms such as bedrooms or lounge rooms. In terms of windows, they generally have a lower sound insulation than the walls they are located within. As a result, highly sound-rated bounding wall systems may become ineffective by virtue of nearby poorly sound-rated windows. For window performance improvement, consider locating windows so that they do not face noisy areas, as can be seen in this example, where the bedroom window is better placed away from a neighbouring balcony. Also, try to provide adequate separation between windows in adjoining SOUs, moving them as far apart as possible. Also, consider using fixed glazing in lieu of opening windows, or using thicker glass, or better still, double or even triple glazing. Other window considerations include reducing the area of windows in the facade, filling any voids between the wall frame and window frame with an appropriate acoustic sealant, and using acoustic sealing strips or gaskets. As with windows, doors can also provide a weak link in sound-rated wall systems. So, where sound control is desired, solid core doors should be used and should be treated with soft acoustic gaskets at interfaces with door jambs. Threshold closers at the bottom of the door, or air seals, will also reduce sound transmission. In most cases, the sound rating that needs to be met will require the use of gaskets and seals. Sliding doors should also be avoided where optimum sound control is desired. The location and detailing of services are two of the most important considerations in controlling sound transmission in residential buildings. Generally, services and service penetrations should not be located on sound-insulated walls between SOUs, but rather on internal walls or dedicated sound-resistant service shafts. In all instances, service pipes should be located away from noise-sensitive parts of the dwelling, such as bedrooms, as shown in this illustration. So, looking at the apartment layout illustrated, let's now look at some of the good spatial design approaches and some of the poor ones. This example provides good practice where the adjacent living and kitchen areas adjoin. Also good practice where bedrooms are located away from neighbouring units. Service ducts have also been used here, located away from bedrooms. Bad design can be seen where dissimilar rooms adjoin, such as these bathrooms and the kitchen backing onto an adjacent living room. This is particularly an issue with laundries, where washing machines and dryers in use can pose serious, significant vibration issues. Locating bedrooms adjacent to common stairwells is also not preferred. Where possible, door entries directly opposite one another should be avoided. And finally, the kitchen service duct located in the wall adjacent to the neighbouring living room is not optimal and would have to be carefully detailed to minimise sound impacts. So in summary, some of the key spatial design considerations include: don't back noisy areas onto quiet areas. Try to ensure quiet areas match quiet areas. Ensure that service rooms in one dwelling back onto the same type of rooms in an adjoining dwelling. Locate windows so that they do not face noisy areas. Provide adequate separation between windows in adjoining SOUs. Consider fixed glazing or thicker or double glazing. Utilise acoustic sealant strips and gaskets. Use solid core doors with threshold closers. And take care in locating and detailing service pipes to control sound transmission. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.